Hello guys, welcome to video number 4 of the forces series. In today's video, we're going to talk about magnitude and resultant of forces. In the previous video, this is where we landed ourselves and we got resultant in x to be negative 2.356 and resultant in y to be negative 10.814. If this is your very first time again watching my channel, please take a time of your busy schedule, should I say busy schedule, and just subscribe to the channel. It won't take you much time, about a second or two. And also don't forget to press on the notification bell, as to this will give you the opportunity to receive notifications when I post new videos. So in this particular video, we're just going to focus on resultant of forces. We now know the resultant. We know the resultant in x to be negative 2.356 and resultant in y to be negative 10.814. Let me take this to the other side. No, let me wait until, let me take this to a fresh page so that we start from there. Okay, let's go to a fresh page. Okay, so like I said, this is where we got ourselves the last time we went through this one. Now, what this implies is that if I'm to draw my Cartesian plane, our regular Cartesian plane, that is our x, y axis, and represent these forces over there, let me get, there is not even, but let's take it like that. Okay, so this is telling us that to the x side, to the x axis, there is a negative 2 points. The leftover force in the x-axis is negative, or 2.356. Because of this negative, we know it's going to the left, and the y is also negative. This is going to be in the third quadrant because both of them are negative. First, let's indicate this using an arrow. So this is our resultant force that we calculated for. Note that our x component of the resultant force was negative 2.356. Let me just drop the negative because the negative over there doesn't really mean the force is negative. It's just showing the direction. And since we've indicated it at the negative side of the x-axis, we are good to go so that we don't confuse ourselves in our subsequent calculations. In the y direction, there's also negative 10.818. And again, negative is just to show direction. This is negative, which implies that it's going towards the negative y-axis. So let me just indicate 10.814. Now, the magnitude of the resultant force, which is basically the absolute value of R. Now, if I'm to complete the force diagram, just like we started doing from the beginning, yes, there's going to be a completed force diagram. You can see that it's forming a 90 degree, so you can say that it's a right angle triangle with one of its sides to be 2.36 and the other side to be 10.841, which I can also bring the 10.841 to the side. Now the magnitude is just the length of the hypotenuse. From Pythagoras theorem, we know that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So in this case, since the side is resultant in x and there is resultant in y, I can see that the resultant squared, the square of the resultant, is basically equal to the square of the resultant in the x direction plus the square of the resultant in the y direction, leaving us with the resultant force to be equal to the square root of resultant in x squared plus resultant in y squared. Okay, so in this case, you can use this one to calculate for the resultant of the, the magnitude of the resultant force. So the magnitude of the resultant force in this case is going to be equal to the square root of 2.356 squared plus 10.814 squared. As you can see, I'm not really using the negatives I got in the previous video. Now, this is just an advice. If your trigonometry is very strong, if you've got a very strong background in trigonometry, you can go with the negative with the values you get by not dropping the negatives. But if your trick is not so strong, please drop the negatives. Like I said, the negative is just to show directions. So you don't need to really put yourself over there. I'm saying this because when we start dealing with the direction of the resultant force, if your trick background is not so strong and you continue to use the negatives, you can mess up your answer. So let's just be mindful about that. With the magnitude, if you bring the negative or you bring the negative, you're going to get the same answer because eventually it's going to be squared. You know, a negative squared will give you a positive, so it doesn't change anything. Okay, getting our calculator, you can see that there is going to be 2.356 squared plus 10.814 squared as well. And that gives me the magnitude of the resultant force to be 11.068. So this 11.068 newtons. So there's the magnitude of the resultant force. Now from there, we can also look at the direction of the resultant force. Now there's some few things you need to keep note of when you are finding the direction of the resultant force. You first need to find an angle. Actually, the first thing you need to do is to do a diagram representation. So get a diagram representation of the resultant force. After that, place an angle. Select the side in which you want to place your angle. So select angle placement. Select your angle placement. So there's actually a matter of choice, but in most textbooks, you see the angle usually at located to the positive or the negative x-axis. So it's just a matter of choice. Now, the next thing you need to be mindful of is the keywords you use to describe your angles. To describe any angle, try to restrict yourself to these two keywords, clockwise and anti-clockwise. So clockwise or anti-clockwise. Avoid using the northeast, southeast, southwest, southeast. It's very correct to use them, but why would you go through the stress when you can equally just use clockwise and anti-clockwise? So clockwise is basically movements in the direction of our regular wall clock, and anti-clockwise is the opposite direction. Okay, so in this particular question, we looking at there's a diagram. So we're done with the first aspect of the diagram. Now select an angle placement. So let me just go with the usual angle placement, which is to the positive or the negative x-axis. So there's my angle placement. I've done my angle placements. And now I need to find this angle. Then I describe the direction. Okay. So finding this angle, I can use tan theta. So tan theta is equal to opposite. In this case, the opposite is 10.814 over the adjacent, which is 2.356. So this is the area where you need to be very careful with the negatives. If your trick is not so strong, please, like I said, just drop the negatives. You still get the same answer. In this particular question, we are not really going to get ourselves in trouble if you bring the negative or you don't bring the negative, because it will cancel out eventually. This negative divided by a negative will give you a positive. But please try to avoid this kind of situations. Just ignore the negatives and just work it without the negatives. The diagram representation is taking care of the negatives. So let's go on to find theta. I can say that theta, so this implies that theta is equal to the arctan, or let's say tan inverse, the tan inverse of 10.814 divided by 2.356. Okay, so tan inverse of this 10.814 divided by 2.356. Okay, so we're getting the angle to be 77.71. So theta is basically 77.71 degrees. Now we need to describe the direction. That is our last part. So again, the angle placement. If you look at the angle placement, I never placed an arrow to the direction of the angle. Let's think about this. So this is the resultant force. This is the magnitude of the resultant force. Now, the resultant is making an angle to the negative x-axis in this direction. So if I'm to start from the resultant force, I have to move in this direction to meet the negative x-axis. So we're going to factor that in we're going to factor that one in.